May 3rd, 2019. The AB Specialty Silicones facility in Waukegan, Illinois. During production of an emulsion product, two incompatible chemicals were mixed. The chemicals reacted and produced flammable hydrogen gas that ignited, causing a massive explosion that killed 4 workers and destroyed the company's production building. AB Specialty Silicones manufactures silicone products used in a wide variety of applications, from personal care to roof coatings, for distribution worldwide. One of those products is an emulsion commercially sold as Andasil EM652, which is used as a waterproofing agent. AB Specialty manufactured EM652 using a batch process. It was produced in a part of the facility known as the Low Bay Emulsions Area. On May 2nd, first shift operators started the process to manufacture the first of 2 back-to-back batches of EM652. They obtained a form called a batch ticket, which detailed the operation steps. For the first batch, the operators staged the chemical ingredients used to make EM652, including a polymer known as Andasil XL10. The operators then followed the steps outlined in the batch ticket to manually add and mix the chemical ingredients in a tank inside the production building. The operators then delivered 2 sequential product samples to AB Specialty's Quality Control Department. The QC department found the pH of both samples of the first batch to be too low, and in both cases required the operators to increase the pH of the batch by adding a solution of 10% potassium hydroxide in water. The operators brought drums of the 10% potassium hydroxide into the emulsions area and added the necessary amount to the first batch of EM652 product. A third sample, delivered to the QC department, revealed that the pH was correctly adjusted, and the first batch of EM652 was approved for packaging. Sometime before 8 p.m. on May 3rd, a second shift operator likely obtained the batch ticket with instructions for how to produce the second batch of EM652. This batch required the use of 8 drums of XL10. There were also likely 2 or 3 drums containing 10% potassium hydroxide remaining in the emulsions area. As a result, there were up to 11 nearly identical drums containing both XL10 and 10% potassium hydroxide in the production area. The operator added the first 2 ingredients to the batch tank, which included XL10. But at some point, while completing the initial steps, the operator likely misidentified the 10% potassium hydroxide drums that remained in the area for XL10 and incorrectly added potassium hydroxide to the tank. Potassium hydroxides that remained in the area for XL10 and incorrectly added potassium hydroxide to the tank. Potassium hydroxide is highly reactive with chemicals that contain silicon hydride bonds, such as XL10. The reaction of these chemicals rapidly produces flammable hydrogen gas. Shortly after the chemicals were mixed, the contents of the tank started to foam and overflow onto the floor. The operator began to yell, and several additional workers ran to the emulsions area in response. A fog also formed, which spread through the low bay. The workers did not realize the material released during the upset was hazardous, and there were no functioning gas detectors to warn them to the dangers of the hydrogen gas. The workers did not evacuate the building. 2 operators were directed to ventilate the building, but before they could take effective action, at about 9:35 p.m., the hydrogen gas ignited, causing an enormous explosion and fire. 4 AB Specialty workers lost their lives, and another was injured. The manufacturing building was completely destroyed. Following the incident, the Chemical Safety Board launched an investigation and found that a number of safety issues led to the fatal explosion. One such safety issue was that AB Specialty did not have a written procedure requiring employees to separate 10% potassium hydroxide drums from XL10 drums in the emulsions area, or to remove leftover containers after use. This, plus the fact that the 2 incompatible chemicals were stored in nearly identical blue drums, made mixing of the 2 materials all too possible. The design of the batch equipment and ventilation system likely led to the severity of the incident. The emulsion process tank had an open hatch-type lid and no vent pipe to direct gases to a safe location. As a result, the hydrogen gas produced during the incident released directly into the production building where workers were located. And the production building's ventilation system included an air mover, which was designed to introduce outside air to the building and was positioned near the location where EM652 was being manufactured. This may have helped distribute the hydrogen within the production building, where it mixed with air, creating a large and explosive gas cloud. The CSB learned that during the incident, workers knew that a process upset had occurred, but they did not recognize the hazard of flammable hydrogen gas. Hydrogen is a colorless and odorless gas, indistinguishable from air, without the use of additional technology, such as gas detectors. But the CSB found that the production building did not have a hydrogen gas or flammable gas detection and alarm system. Such a system could have automatically activated an alarm to alert workers to the danger they were facing, making it less likely they would have remained inside the production building between the start of the hydrogen release and the time of ignition. And the CSB found that the workers lacked effective emergency preparedness training to recognize the potential for a hydrogen gas release and know to immediately evacuate if a possible release should occur. AB Specialty Silicones develop hazardous gas detection and alarm programs and associated procedures. These should be based on manufacturer specifications, current codes, standards, and industry good practice guidance. The programs and procedures should be developed for all hazardous gases that could be released near workers, including hydrogen, and must address proper installation, calibration, inspection, maintenance, training, and routine operations. The CSB determined that many of the safety issues that led to the explosion at AB Specialty could have been identified if the company had an effective hazard analysis program. Instead, AB Specialty assessed its manufacturing operations through a program it called Technical Service Requests, which evaluated a mix of business and safety risks. The process did not and was never intended to assess the hazards of performing an operation or to establish safeguards to reduce risk. At the same facility in 2014, a drum containing EM652 exploded as an operator inserted a charging wand into the drum. The operator sustained short-term hearing loss from the explosion. After, AB Specialty concluded that a lack of comprehensive hazard analysis, among other things, contributed to the incident. But despite knowing their hazard analysis program was inadequate, AB Specialty did not make needed improvements after the 2014 incident, such as requiring systematic reviews of process hazards. This points to a weak process safety culture at AB Specialty that did not promote effective safety management systems. Had AB Specialty instituted a safety management system that addressed process safety, including a robust hazard analysis program, the company could have identified the serious safety hazards associated with its manufacturing operations, including storing reactive chemicals in similar containers, the practice of allowing incompatible materials to be stored near each other, the problematic ventilation system and batch tank design, the lack of a gas detection system, and its insufficient emergency preparedness.